In this lesson, we're looking at geometric sequences, so let's go ahead and get started. So what is a geometric sequence? Well, a geometric sequence is a sequence where the ratio of any term to the previous term is constant. And so to get the next term, you simply multiply that previous term by the common ratio. What is the common ratio? Well, that is found by dividing each term by its previous term. Now for these problems here, we want to determine whether or not these are geometric sequences. If yes, we want to identify the ratio. So as stated earlier, there has to be a common ratio. And so what we want to do, I'm going to start at the last term here and start dividing. So 250 divided by 50 is 5. 50 divided by 10 is 5. 10 divided by 2 is 5. And so, yes, this is a geometric sequence, and my common ratio is 5 because I have a constant ratio of 5 right here. Let's take a look at the next one here. 5 divided by 15 is 1/3. 15 divided by 45 is 1/3. And 45 divided by 135 is also 1/3. So again, that constant ratio. So yes, that is a geometric sequence. My common ratio is 1/3. Let's take a look at the next one here. 30 divided by 24. I can just reduce that. If I divide by 2, I get 15 over 12. Dividing again, they're both divisible by 3. So that would be 5 over 4. So let's see what happens next. 24 over 18, I'm going to reduce that. I always start by divide. Well, I could divide by 6. 24 divided by 6 is 4. 18 divided by 6 is 3. And so that does not have a common ratio. And so that is not a geometric sequence. Let's take a look at number 7. Negative 56 divided by 28 is negative 2. 28 divided by negative 14 is negative 2. Negative 14 divided by 7 is negative 2. So geometric sequence, that it is. Common ratio is negative 2. The next one here, negative 10 divided by 20. We can reduce that. That is negative 1/2. 20 divided by negative 40, again, that is negative 1/2. Excuse my handwriting, and it's all bunched up here. And negative 40 divided by 80, again, is negative 1/2. And so common ratio is negative 1/2. And yes, that is a geometric sequence. Negative 576 divided by negative 144 is 4. Negative 144 divided by 36 is a positive 4. And negative 36 divided by negative 9 is positive 4. So the last one I have here is a geometric sequence, and my common ratio is 4. And again, I just start at the last term and start dividing from right to left to get that common ratio. Now we have some problems here that tell us that they are geometric sequences, and we just want to find the next 3 terms. And the first thing we have to do is figure out that common ratio, and we simply do that by dividing from right to left. And so since I know that these are geometric sequences, I like to pick the smaller numbers. And so instead of starting at the last number like I did previously, I want to start with these two, so because they're easier to divide. So negative 21 divided by 7 is negative 3. So my common ratio will be negative 3. So I could simply multiply 63 times negative 3 and so forth. So my next 3 terms are negative 189, 587, and 1701, or negative 1701. Because 63 times negative 3 is negative 189. Negative 189 times negative 3 is a positive 567, and positive 567 times negative 3 is 1701. So I'm just dividing everything or each term by negative 3. The next one here, number 8, these two here, I'm just going to take my calculator and divide since I have large numbers. 192 divided by 768 gives me 0.25 or 1/4. Since I have such large numbers, I'm just going to deal with decimals here. So 0.25. So 192 times 0.25, that would be 48. And 48 times 0.25 is 12, and 12 times 0.25 is 3. Or you could say that 0.25 is equal to 1/4. So you can say 48 times 1/4 is 12, or 48 divided by 4 is 12. And so several ways you can do that when you have fractions, just whatever is easier for you. The next one here, 4 and 2, so dividing from right to left. 2 divided by 4 is 1/2, or 0.5. And so next, our next three terms, half of 2 is 1, half of 1 is 1/2, half of 1/2 is 1/4, or I could simply multiply each term by 1/2. So 1 times 1/2 is 1/2. 1/2 times 1/2 would be 1/4. And so again, I'm just multiplying. And my last one here, negative 25 divided by 5 is 5. So I just picked these because they were the smaller numbers. And so I'm multiplying everything by 5. So those are my last three terms, or my next three terms. And so again, when you want to find the terms in a sequence, identify the geometric sequence, identify that common ratio by dividing from right to left. So this way. And then multiplying each term by that ratio. So let's take a look at the geometric sequence formulas. So first we have the recursive formula, and that formula gives the value of a specific term based on the previous term. So the recursive formula is a sub n equals a sub n minus 1 times r. So if we want to write a recursive formula, the only thing we would need to figure out is that common ratio and plug it in for r. So if we had this geometric sequence here, which is the very first one we looked at, our common ratio would be 5 because we're dividing 250 by 50 is 5, 50 divided by 10 is 5, and so forth. So if we wanted to write a recursive formula, that would be a sub n equals a sub n minus 1 times 5, and that would be it. Explicit formula, that each term in a sequence can be calculated directly without knowing the previous term's value. It gives the value of a specific term based on the position, and we could find the nth term by using this formula. So that is a sub n equals a sub 1 times r raised to the n minus 1 power. A sub 1 is the first term, and r is the common ratio. And so the example that we have up here, if we wanted to write an explicit formula, we could just do a sub n, or just write a sub n equals, our first term here would be 2, so that would be 2 times our common ratio is 5 raised to the n minus 1 power. And so that would be the explicit formula for this example here. Or you may see the formula written this way. You have your first term you have this dot here. So either way, those are explicit formulas. For these examples here, we want to write a rule for the nth term, and so we want to use the explicit formula, and we want to find a sub 7, or basically the 7th term. So the first thing we need to identify is a sub 1, which is our first term. Our first term is 3. Our common ratio, let's divide here. 9 divided by 3 is 3. And I can only do these two because we know if we're asked to write a formula that this is a geometric sequence. So I'm just dividing these two. And so my common ratio, or my ratio, is 3. So I can simply fill it in. A sub n is equal to 3 times 3 to the n minus 1 power. And that is my formula. Now I want to find the 7th term. So basically I just plug in 7 for n. So a sub 7 is equal to 3 times 3. So instead of writing n, I'm going to write 7 minus 1. And just simplify. 3 times. So 7 minus 1 is 6. And I still have to use order of operations. So I'll do 3 times 3 to the 6th power. 3 to the 6th power is 729 times 3. And that gives me 2,187 for my 7th term here. All right, the next one, my common ratio, 20 divided by -4 is -5. And so first term is -4. That common ratio is -5. So my formula, a sub n equals -4, because that's my first term, times, since I have a -5, I'm going to put that -5 in parentheses so I don't have two signs next to each other. And then just put my n minus 1. So that is my formula. And I want to find the 7th term. So plugging in 7 for n. I'm just going to go ahead and do 7 minus 1. It's going to give us 6, right? -4 times, so -5 to the 6th power. That is 15,625. Leaving that in my calculator, I'm just going to multiply by -4. And so that gives me 62,500. So my 7th term for this sequence is 62,500. Okay, so I have some problems here that I would like for you to try on your own. Just like I did for the previous two problems, write a rule for these geometric sequences and then find the 7th term. So go ahead and pause the video and try these problems on your own. Okay, so I have the answers here. The rule is boxed and in red, as well as the 7th term is boxed and in red. So go ahead and pause the video and just go ahead and check your answers. Hopefully you got them correct. For our application problem here, it says the table to the left shows a car's value for 3 years after it is purchased. We want to write a rule to represent the car's depreciation. And so to write that rule, we need our first term, or our a sub 1. So at year 1, that car was at 10,000. So my a sub 1 is 10,000. My common ratio. So now since we have a table here, to find that common ratio, remember we divide by the previous term. So I'm going to use 10,000 and 8,000. And so in this case, 8,000 would be my previous term. And so that is going to go in my numerator. So 8,000 divided by 10,000. I want to reduce this. So they both have 3 zeros. So I can cancel out these zeros here and simply reduce 8 over 10. And that reduces to 4/5. So my common ratio is 4/5. So I just want to plug it in. So a sub n is equal to a sub 1, which is 10,000, right? Then r, so this is a 0, times 4/5 to the n minus 1. So that is my rule. Ooh. That is my box. Now it says, what would be the value of the car after 10 years? And so I simply plug in 10 for n. So a sub 10 is equal to 10,000 times 4/5. So n minus 1, that is 10 minus 1. I'm going to go ahead and put 9 because 10 minus 1 is 9 if I plug it in to my formula. And then multiplying. So again, order of operations. I want to do 4/5 raised to the 9th power. So I just put in my calculator 4 divided by 5. I hit enter, raised to the 9th power, and I get 0.134217. So really long number. I'm leaving that in my calculator and I'm going to multiply by 10,000. And that gives me 1,342. And since we're talking about dollars, we round to the nearest hundredth. So that is, I got 1.77. So rounding that to 0.18. And since this is money, put my little dollar sign here. And so after 10 years, this car is only worth $1,342.18. So that was the last problem of our lesson. Hopefully you understand geometric sequences at this point or a little bit better. And I want to thank you for learning with me.